Hello everyone, welcome to today's video. This is an absolving attempt of this Codeforces Round 921 that happened last Saturday at 8 p.m. in the evening IST. So I'm going to solve few problems. I'm going to reflect on the approaches, the techniques that I used to solve these problems. This is mainly designed for the Div2 participants or even those who are aspiring to start programming or competitive programming afresh, or maybe after a point of time, after a long time maybe. So I believe you will get some fresh insights from this video and develop your programming skills. So yeah, let's get started. This is a small introduction about myself. I'm a software engineer 3 at Google. I've been to the ASM ICPC regionals 3 times. I've been 3 times in the top 2000 in Facebook or Meta Hacker Cup. In Codeforces, I've been a master, and in CodeChef, I've been a 6-star. I've undergone BTech honors in computer science and engineering at IIT Bhilai. Among the extracurriculars, you may say, I had been a former member of National Blockchain Project, IIT Kanpur, and I have a small publication in edge computing at CC Grid 2021. Apart from this, I've had some good records in some hackathons. Like in Expedia, I had some position in the top 10. I also went to the finals of the Hack with Infi, which Infosys I think holds even now. They used to hold every year. I hope it happens even now. And also, as a team, we won gold medals and other awards at certain hackathons and team events, intra-IT tech events and all. So yeah, that's pretty much about myself. So now coming to a bit closer to my CP profile. This is the profile that I've been using over a good time from now. This is where I started around 2019. This is where I am 2024, and this is basically the first problem, this first contest I gave this year in 2024. As I mentioned, I came from this master tracks, but yeah, there have been ups and downs, and that's pretty much the most interesting part of the competitive programmer's journey. Okay, so going to the most important thing now. This is about today's yesterday's or Saturday's contest. But before I go there, if you want, you can follow this. You can basically during your contest, you can basically follow this. You can message me over here for any, and you can basically see my submissions and contests. All these information are over here. Even from my own college and folks, basically you can see all these things. So yeah, feel free to connect. Now going back, so getting started, we have 6 questions over here. This session is going to be about 5 questions. Basically the top 4 questions which I could solve in the duration of the contest, and then the 5th question which I solved to a good extent, or basically I have had some good understanding of it. I did not get the time to really code down the solution and submit it, but I'll share some insights. Take them, or feel free to take them and try applying that and try to implement. If you have any doubts, definitely you can ask me here or there, wherever. In LinkedIn you can find me. So yeah, let's get started with these questions. The first question, we got everything covered. Yeah. So what this says is we have two positive integers n and k. Your task is to find a string s such that all possible strings of length n that can be formed using the first k lowercase English letters occur as a subsequence of s, which means that all possible strings that can be formed using the first k lowercase letters, all possible strings that can be formed using the first k lowercase letters, that is, if k is 3, that means a, b and c. If k is 5, a, b, c, d, e. So using that, all possible strings of length n that can be formed, they must occur as a subsequence of s, and you have to find that s. You have to find a string s such that all these strings can be formed as a subsequence. The definition of subsequence is given. We know basically it should be occurring in parts in a certain sequence. There may be other elements between them. So this is the formal definition of a subsequence. And this is where the most important part is. If there are multiple answers, print the one with the smallest length. Very important for competitive programmers. So when we read the question, we basically try to get the idea of the question in the first 10-20 seconds, maximum 30 seconds. The smallest length thing somehow got eclipsed. And ideally, I mean, I would have expected maybe this would have been in bold, but anyway, it's totally up to the author. They can choose to not to keep it in bold, not to keep it highlighted. But this is a very important point. I perhaps would have, had I not noticed this, I would have approached in a completely different way. I would create such a string that in all the test cases that would be valid. It wouldn't be the smallest length, but it would contain all the subsequences. But anyway, that would go wrong. So coming back, it needs to be of the smallest length. Okay, now we have these test cases. What we see is when n is 1 and k is 2, that is length 1 and 2 letters, we have AB because both A and B, these are the two subsequences. So let us see how this question basically turns out. This is question A. Okay, so when n equal to 1, k equals to 2, what basically comes up is, okay, n equal to 1 means all subsequence, all sequences or all strings of length 1 possible using the using the first two lowercase letters. So k equal to 2 basically means a and b. Basically means a and b. Now of length 1 what are possible? Using the letters a and b, you have a possible, you have b possible. So from here you can see that, okay, a can be extracted or b can be extracted. So ab is that string from where a and b can be extracted. Can we name another string? Yes. Ba can also be the string. From B also we can take out B, we can take out A. A and B's should be, I mean, it should be possible to extract A and B. That's the only requirement. So that is possible. Fine. Now let us look at another example. Let's say n equal to, let's look at this. N equal to 2 and k equals to 2. And over here it's given BAAB. Let's go there and see. N equal to 2, k equals to 2. What it basically says is, okay, k equals to 2 again means the same thing. It again means the same thing, that, okay, it's A and B. K equals to 1 means only A. K equals to 2 means AB. And so, basically, when n is equal to 2, what we are basically saying is that all the strings of length 2 that are possible using these letters, repeating them or not repeating them, they should occur as subsequences. So what are possible using this? AA, AB, BA, BB. These are the possible strings. They should occur as subsequences in the given string. So what can the given string be? What can be the string of the minimum length? If we look at the answer that is given over there, we see BAAB. This is the answer for this case, which is given in the sample test case. So how is this satisfying? AA occurs over here. This is AA. AB. AB occurs over here. AB need not be consecutively placed. So this A and this B also forms this AB. Okay. So this is a subsequence, not a subarray. That is the difference between a subsequence and a subarray. Similarly, BA. BA we have over here, and BB. BB we have over here. So this B and this B. This basically gives us this, this. Okay. So every string that is possible with the given rule n equal to 2, k equal to 2 is present as a subsequence in this given string BAAB. Is some other string possible? Let us try. Let us see something like A, B, A, B. If I have A, B, A, B, is it possible? Okay, A occurs, so A is fine. AB occurs, AB is fine. BA occurs, so BA is also fine, and BB occurs, so BB is also fine, which means this is also fine. Is any permutation possible? If I look at AA, BB, now let us see. Is AA possible? It is fine. AB is possible. BB is possible, but BA is not possible. Can you see this? BA is not possible. BA is not possible, so this particular permutation is not possible. So nothing, I mean, not everything will be the answer, but there can be many possible answers. You need to find out one correct answer. This is a correct answer, this is a correct answer. Okay, so now how to solve this problem? This is one of those problems. Um, if you look at my submission, my standings, okay, lot many over here. Okay, if you see my standings, you see that the first question I've solved in 5 minutes, second question in 14 minutes, third question in 23 minutes, fourth question in 1 hour 37 minutes. So the first question, if you see 5 minutes, basically most of it got consumed in understanding what the question really wanted. But this is one of those questions, or Codeforces Round A is one of those questions where you should be able to solve the question faster than you are able to explain how the problem gets solved. Let us see what the comical thing happens over here. The first thing, if you have to understand it correctly, the first thing that you should be interested in, okay, what is the minimum length that the answer should be of? I see different types of answers, but what is the minimum length? What I see over here is that the length is 2. What I see over here is that the length is 4. For the other examples that I have, if I go over here and see, for the other examples that we have, 2 and 3, what is the length? ABC, BAC. Length is 6. So that automatically gives some idea to my mind. That automatically gives me some idea which we can implement directly. If it works, very good. If it doesn't work, fine. Retry. Basically, what turns out is that the length is somewhere the product of n and k, but not jumping over there. Let us see how we can analytically make a much more logical argument. So let us, sorry. Yeah. So the first point is AA should be possible, BB should be possible. Now, let's say we have some n and we have some k. How many times does my, let's say k is equal to 3. In my string, how many times should the character A appear? I can analytically say, hey, k must appear 3 times because A should be a possibility. So A must appear 3 times. How many times should B appear? B also must appear 3 times because B should also be a possibility. I'm sorry. So I'll rectify it. Let's say n is equal to something like 4. Now what can I say? If n is equal to 4, that means all the strings using ABC, this 3 basically means ABC. Using ABC, all possible strings of length 4 should be there. So if I just look at A should be a part, which means that A must be present 4 times for this to be a part, which means A has to be present 4 times. Similarly, we can say that BB also is a part. BB is also a part of, must be a subsequence, which means B has to be present 4 times. Same goes for D. What I'm saying is among this, just like this will fall in the possible subsequences, in the mandatory subsequences of the string that I'm trying to form. C must be present 4 times, D must be, okay, D is not there, so ABC, that's it, ABC is there. Which means that each character must be present n times. This is the total length I must be reaching. My total length has to be greater than equal to this. Why? Because these characters definitely I need. Apart from this, if I need any more characters, I may need. But what we first understand is each character must be present k times. Got it? So that's it. Now you can basically say, okay, if I can form something like this, each character, how many characters must be present? K characters. Each character n times. I'm sorry for the n times. So there are k characters, each must be present n times, which means there has to be nk total characters at least. Now the question arises, is nk sufficient? Is nk sufficient? What we saw over here is that nk when used in a wrong permutation was not sufficient. So placing all the A's and all the B's and all the C's, this approach should not be working, because we already saw a bad point, which is after B, if A comes, if I'm looking for that subsequence, I won't be getting. What is one way? One way can be, okay, this is a very popular technique which is used, that hey, I want strings of length 4, so for the first character of anything, for the first character of any of the subsequences I'll be forming. There are other subsequences as well, for example, A B A C A C A B C B C B and so on. I mean, so many subsequences should be possible. So many possible strings are there using the k characters. So now my thought process will be, hey, how soon can I ensure, in how many characters can I ensure that, okay, my first character of whatever subsequence, my first character of whatever subsequence is required will come from here. How soon can I guarantee? So basically, if I say, hey, I'll start with ABC, what does this guarantee? This guarantees that, hey, any substring, whatever you basically ask of me, any of these will start with one of the characters over here, A, B, or C. And it need not be in the same way. It can be BAC, it can be BCA, it can be anything. Basically, ABC, if I keep at the beginning, this ensures that, okay, up to here, the first character will be coming. Whatever substring, whatever subsequence I'm looking for, I'll get the first character from over here. Any permutation. Next, once again, I can have another set of ABC, another set of ABC, another set of ABC. What does this guarantee? That whatever so what we have seen, that 4 into 3 is the minimum number. I'm checking, okay, with the minimum number, can I make up something? This is what I made up. What does this tell me? Hey, if you want any 4 character 4 length string using ABC, does this guarantee? This does guarantee. Why? Because the first character you will definitely get from here, second character you will definitely get from here, third character you will definitely get from here, fourth character you will definitely get from here. You can get faster, but this is a deterministic way. Whatever string you give me, I'll be able to find out from here. So I found out a lower bound, and now using the lower bound, I just thought a bit, hey, what are the possible strings? I mean, how can I basically throw 12 characters over here so that I can get any string? And then I thought that, okay, let me go character by character. I require a character A, B, or C, and then I say, okay, that's where my character A, B, or C can be or needs to be. Let me try to accommodate it as fast as I can, and that's where in the first 3 characters I kept things in such a way that I'll get one of those that I want. I'll get the first character of whatever string I want. Okay, so this basically explains, if I look at, so the given example is n equal to 2, k equal to 3. So you can see n equal to 2 means 2 times it has to occur how many characters? 3 characters, ABC. So first 3 characters ABC, next 3 characters again ABC in a different permutation. The order doesn't matter, because from these 3 characters I'm looking for an A or B or C. Fine. So that's it. That's what I did in the first 5 minutes. Here it might seem that, okay, we have so many possibilities to think about, so many conditions to think about, but in practice, yeah, it depends on how much time you have spent, etc. For a long time I have been away from it, but still, otherwise probably it would have been faster. But if you look at my code, that's how it goes. Yeah, there you see, I took the inputs and then I basically said that, yeah, print ABC, ABC in that way. So this guy is going to print that ABC once, ABC or ABCD, whatever, k characters, it will print once. J equal to 0, J less than k, so it's just k characters once. And then I'm printing that n times, the same thing n times, and finally the extra line. That's it. So ideally, yeah, if you are in practice, this should take much lesser time than I took over here. Okay, that's our first question. Okay, so now we are going to look at the next question. Before question B, I will look at question C because it is quite similar. Let us go and take a look at question C. Here's question C. Did we get everything covered? Very similar question. A string is called a subsequence of another string if A can be obtained by deleting some characters from B without changing the order of the remaining characters. The same thing. And now you have to print this. So check whether all possible strings of length n can be formed using the first characters. First lowercase English. Okay, so now the S is given. The string is given and you have to check, hey, using this string. Now you are not asked to make the string. The string is given, you are asked, hey, can this be the answer of that? So can you see the first question asked you that, hey, is a string possible? And now this string asks you, okay, the first question asks you, what is that string? What is that string of minimum length? And now this string asks you, or this question asks you, that, hey, I'm giving a string, tell me whether this string can be the answer or not. Let us look at the test cases. 2 to 4. What is 4? Okay, the length of the string, which is given. So 2 to. And one important thing is here it's not necessary that this S is of minimum length. You just have to say whether all the subsequences are there or not. That's it. You don't have to say whether it's a minimum length or non-minimum. You don't have to worry about that. Okay. Now M goes up to 1000. Again, similar constraints for N and K. And what we see over here, 2 and 2, N and K. So ABBA looks fine. So yes, this string is valid. 2 to 3, we have already discussed. 2 and 2 means A has to occur twice, B has to occur twice. Here A doesn't occur twice. So it's easy to say, yeah, no. And then 3, 3, 10. So 3, 3 means ABC, ABC, ABC. In that way, it could have done. In this case, it's saying no, and it's also saying, hey, CCC is missing. CCC is that subsequence which is missing, and that's what has been asked in the question. If it is no, print a string which cannot be found. Which cannot be formed as a subsequence of S. So print a string using the first K lowercase English letters, which is not a subsequence of S. So CCC is one such string which does not occur over here. Now, some basic ideas can be, hey, let me count the characters, because for the given cases that is sufficient, but that is not sufficient because let's say for this kind of an example, if A, B, B is given, and if this n equal to 2, k equal to 2 is given, A, B, B is not satisfying, but the counts will satisfy. A occurs twice, B occurs twice. So this is not sufficient. So as a computer programmer, when I know that a certain approach would work only for few cases and not for all cases, I'll not usually spend time in that approach. I'll think something which will work for all possible examples, which would, so that my effort is not double. I'm first solving for few examples, then for other examples. That does not incentivize the points and rankings and all those things. So how to solve this problem? This problem basically is that, let's say somebody has given an answer to the first problem, problem A, and now we have to check whether the problem is correct or not. So this problem basically does that. This problem basically takes a string and says that, okay, this is correct or not. In addition to that, I mean, for problem A's checking, we also need to check whether the length is final. Here, the length is not a factor. You can have more characters. You cannot have less characters. You cannot have the deficiency of these required strings as subsequences. So, okay, let's get started. Question C. Now, you are given a string. Let's say we have that A, B, A, B, B, C, A, A, B, C, A. A long string, if I say that okay, n has to be 3, sorry, n has to be 2, and k has to be 3. Many such strings will be possible. For example, um, AB, AB, BA, AB, AB, BA, ABB, AAB. This is a valid substring, etc. All these things are valid. But what is required of you is you have to tell me such an example which satisfies this and which is not a part of this. What is one such example? So if I try to find it is, I can pick up this C, I can pick up that C and then B, something like this. If I search for CCB, CCB does not occur over here, I believe. So CCB, you can't have CCB as a subsequence. Subsequence means you can't change the order. If you pick up CCB from here and say, hey, I'll change this order, this you can't do in a subsequence. So that's where we are. CCB is an example due to which the answer over here will be no. After no, you have to print CCB. Now, how did I find out this CCB? Or how can you find out this CCB? So look at it. Whenever you have to find out such a string, such a negative example, counter example, what do you have to do? You basically have to see there are greedy possibilities, there are non-greedy possibilities. Greedy possibilities are those where if you try to apply a local greedy process, which means local, if you try to see which is the most difficult up to the length 1, then up to the length 2, then up to the length 3. So you go length by length. Like in question A also we used length wise process. For length 1 we said let me have everything ABC. For length 2 again ABC. Similarly over here also if I use the same process, that hey, let's have let me try to make such a string which will be difficult from the very beginning. In what sense? So if I say okay, I have to form of length I'm sorry, I used let us have 3. Let us have 3. We can have another C over here or whatever. So n equal to 3, I'm sorry. So this categorizes for n equal to 2, k equal to 3, it would have been a yes. For n equal to 3, k equal to 3, it is a no. Yeah. Now coming back, what can we do? If I have got this particular thing, n equal to 3, I will say, okay, I need a string. Let me try to form a string. If I cannot form, very good. I'll not be able to form. So fine. While I'm going over here, the easiest to start with, a string can start with A. Why it is the easiest or why it is the best for constructing such a subsequence? Because the first character only gave you the first character of your string. So you have so many characters left for the remaining 2 characters. So the sooner you get the first character, the better it is. I want to make it the worst. I want to find out that subsequence, that string which is not a subsequence over here. So I'll make it harder. What will I do? I'll basically say, hey, if I pick up A, you will have so many possibilities for the second and third characters. If I pick up B, you will have again many possibilities for the second and third characters. Second and third characters. If I pick up B over here, you will have so many possibilities. However, if I pick a C, you have only these few characters. If I pick up a C, you have only these few characters. After this only you can pick up the second and third characters. So I can say, hey, let me try this. I'll pick up C as the first character. This is the string I'm going to target. Understand this, that instead of C, had I used A or B, the situation would always be easier for me. The situation would always be easier or as much difficult as that one. It cannot be tougher. So if I start with A, definitely I have more possibilities. I don't want more possibilities. I want to corner it in such a way that I get a failure. So this is what I get. I pick up a C and then after C I can say, hey, now what is the hardest to get? Again I see from A, B, C. I see that C is the hardest to get. C leaves me with the minimum options. If I pick up this C, then it leaves me with the minimum options and hence I choose this C. So once again, A is there, C is there. So From here, I'll say, okay, I'll not pick A, I'll not pick C. What comes after that? Okay, B is remaining. B I'm not getting, so this helps me directly that, hey, this set has not completed. So in the first ones, I've tried my best to delay as much as I can. What did I do in the previous one? In the previous approach where I had to form a string, I said do as fast as possible. As soon as possible, bring me all the possibilities of the first character and so on. In the second question, what did I do? I did exactly the opposite. I basically said, hey, I want to find a string which does not occur over here. If I choose a character which occurs so early, I have such a big probability, possibility to get the entire string. So I will try to delay my first character as much as I can. First character and second character are totally independent. First character and second character are totally independent. I can choose anything as a second character, anything as a third character. So my first character, if I choose as delayed as possible, then that gives me more probability to find out a string which does not occur over here, right? It can be mathematically proven. I'm not going into that because intuitions are more than sufficient for these kind of intuitions are more than sufficient for solving these kind of problems. So after this C, if I basically say, hey, I'm going to target you with C, this C does not occur. This C does not occur. I'm sorry, I'm sorry. So basically B doesn't occur, so I'll say I'll target you with B. So this does not occur. So this is my answer. Let me see if I can get an example. 3, 3, 10, fine. What other example can I give you? Let's say A, B, A, B, C, B, A, C, B, A, C. So n equal to 2, k equals to 3. I'll do that process. So I'll say, okay, A, B, A, B. I'll not pick because picking these means making it easier. I'll pick up this C. So I picked up this C. And next I'll say that, hey, now can you pick up, now let's see what is the hardest for the next character. Again, BAC, so C is the hardest. I'll say, okay, pick up this C. So basically CC, that is the hardest and that is itself possible. So if you see over here, up to here, I have all the ABC present. Again, over here, I have all the ABC present. So these are again those bubbles I am forming. That okay, this is the bubble from where the first character is guaranteed. That is the next bubble where the second character is guaranteed. Here, this was my first bubble from where ABC both were possible. All the three were possible. This is my second bubble from where all the three were possible. This is the bubble which remained incomplete. This is the incomplete bubble. Okay, so this is the relationship between the first and the third problem. Again, the bubble in the first problem, I had the urge of completing the bubbles. In the third problem, I'm basically having the urge of again looking at the bubbles and try figuring out the strings. Again, now you can basically see that the last character of each bubble is the string, is basically getting me towards a string that possibly can be my answer. Here also, here the two bubbles are complete. So whatever string you try will be complete over here. Can you see? Uh, I am always talking about the first part and the second part. If you say that okay, I'll not worry about that. I'll take some other things. That is definitely guaranteed. Here we are completing this bubble. Here we are basically seeing all the k characters are there. So definitely, this is the last resort. If you say this, then that means you're definitely ensuring that the second character does not come from the first bubble. So in a way, you're making it difficult for these bubbles to form. You have to find out a counter examples. You have to be critical, like your toughest examiner. You have to be critical. You have to say, okay, let me make it as tough as I can. We have to explore and go as far as possible to get the first character, second character, and so on. So yeah, that's it. I'll show the code, and we will see if it's in sync with what I just explained. Let me take a quick look. Yeah. Okay. So where are we? Yeah. I'm taking the nkm. M is basically the string length. There's a hash set of character. There's an array list. What am I doing in the array list? I'm basically, am I using the array list? Okay, yeah, I'm using the array list ar dot add chi. This is basically the string that I have found. So if you see over here, what am I doing? I'm forming this bubble, and this is my check whether the bubble has completed or not. If the size is equal to k, if the size is equal to k, that means in my bubble I've got k distinct characters. So from the beginning I'm adding this, and if my bubble's size becomes equal to k, that means I've got that complete set of characters which can give me the first character of my string, whatever string. In this way, now what am I doing? I'm basically adding that last character which completes my bubble as I discussed, and then I'm clearing the hash map for the next bubble preparation, and then C++, which means now one character is completed. The first character or the second character, whatever, is completed. I'm going to try for the next character. If C is more than or equal to n, yes, don't no need to think. If C characters, C bubbles are completed, then it is yes. Otherwise, it is no. So that is very clear. Now, what am I doing? Up to C, whatever bubbles are completed, I am printing ar.getI. You can't print anything. I am printing the last characters because I know the guarantee. I have the guarantee that they will hit that particular case. They will take me to that possibility that there is no, no last bubble. Like over here, if you see, if I don't follow that strategy over here, what do I get? I end up at, let's say, ABC. If I say the randomly, I'll do ABC. Like for these two bubbles are completed, so I'll take AB. You can't take AB. If you take A and B, then AB, and after that ABA is possible, ABB is possible, ABC is possible. You can't take that. So yeah, that's how it goes. So what I did over here was I basically said uh, print all those characters, C characters, and then what I said is now for the next incomplete set, there must be one incomplete set. Print that character which is not in H. This H I haven't cleared yet, the last H. So whichever first character you don't get in H, print that. I have the guarantee that up to K there is at least one such character. Otherwise it would have hit this particular case. So I have that guarantee, and that's why I didn't check whether it's less than equal to K or not. I just said, hey, okay, I basically checked it's up to K. So I'm sure one character will come, and once a character comes, I'm breaking it. So this break is also important. And again, this is another part of computer programming. You have to be careful about all the possible cases and all. So if forget last bubble, if only up to the mid bubble it can go. After the 3-4 bubbles it couldn't even touch. Only out of 8 bubbles it could touch only 4-5 bubbles, let's say. Then the other characters also you need. So basically you are saying these many are completed, you are taking them, you are taking one more character where basically it's a contradiction. But now the question basically says that if you look at the question says you have to print a string of length n. So if you print a lesser string, if you print a smaller string, which may not occur as a subsequence, so logically you may be correct that hey, this smaller string also doesn't occur as a subsequence. So after suffixing it with anything, definitely that will not occur. Logically it's correct, but since the question has said don't, follow this length of n, you have to follow that to the word. So to the letter. So yeah, I have printed those extra characters which can be anything. A, B, but you need to be careful. That has to be less than equal to k. That has to be one of the first k lowercase letters. So don't just print anything A to Z. That's why I chose A over here. So yeah, that's how this question was. Definitely on a better day, this could have happened faster than, as you can see, 8 or 9 minutes. Fine. What else? Now, we'll move on to the next 2-3 problems, but before that, I'll step into one problem. I'll step into one fun fact, which I just noticed. Let me show you. If you go to the tutorial, where you have the tutorial, the hints, the feedback, the solutions, of course not during the contest, these are updated later on. If you see I just noticed this a long time. I have not been participating in this platform. I didn't notice this earlier. Yesterday, day before yesterday was the first time I noticed this. If you look at this, you see how many people have rated this problem as good, okay, bad, and didn't attempt. And I notice an interesting thing. If you see the percentage of people who have, if you see the ratio of good to bad, you will see that it's quite few, and very few people have actually commented. I'm sorry, have commented it as bad. If you go down, what you see is many more people have commented as bad in this second problem. And now if you keep on going down, okay, this is their fun fact. I'll go to the feedback, which is our fun fact. We see that the ratio again increases, but this is again slightly less. If you see the ratio good is to bad, the ratio decreases over here. If I look at this, the ratio suddenly increases over here. 91 is to 89, horrible ratio. So you can see the bad problems, as the difficulty is increasing, people's feedback about this as bad problem is actually increasing. If I look at the last thing, 2e 1b, here again the bad problem ratio is uh, quite a big one. If I go down, very big. If I go further down, what I notice is again bad problem. Here the bad problem count is not that much. So from 1D the bad problem count is not that much. What is special up to here? Up to here we have all the Div2 participants. Unfortunately, the Div2 participants have, it seems like they have vented out their anger over here. So this was supposed to be some kind of probably constructive feedback. I hope that there are some constructive reasons, but what I see is that the bad problem ratio keeps on increasing with the difficulty of the problem. And also another interesting observation is this, that in this problem you have the you have greater this thing. Okay, if I come back to here, this one has a lesser bad problem ratio. Here the bad problem ratio is slightly lesser than this one. What I noticed is that here we have some div 1 participants. For this guy we didn't have any div 1 participants. So here the div 1 participants, I believe, did some moderating job coming over here. It can be the other way also, because A and C are so relevant, probably people found it easy, I don't know. But the other part of the story is that the div 2 participants probably are a bit harsher on the problem setters. I hope that I am wrong, but I found it as a fun fact for today's video. And this was purely coincidental. Fine. So let us go back, let us get started. Let us resume. Did we get everything? Okay, a balanced problem set. Okay, what does it say? It says that you have to basically divide this difficulty x into n subproblems. So instead of one problem, you have to basically have n subproblems such that the sum of their difficulties will be x. Difficulties of all the subproblems are positive integers, right? Positive integers means you can't have 0. Positive means positive, greater than 0. And you have to maximize the balance. What is the balance? The GCD of all the difficulties. So if I make it short, if that is what we computer programmers do. We try to simplify the problem so that we understand it in a crisp way. One values x, you have to divide into few values such that the sum of their values is equal to the x, and they are n in number, and their GCD is the maximum possible. So if I take these examples, 10 3, 10 3, so 10 you have to divide into 3 parts, I believe. So what can you say? You can say, okay, I can divide into 3, 3, 4, or I can divide into 2, 4, 4, or I can divide into 4, yeah, 2, 4, 4, 2, 2, 2, 6, something like this. What is the GCD over here? GCD over here is 1, GCD over here is 2, GCD over here is 2. So what is the best? The best is the GCD 2. I mean, you can have other ways as well, but here the answer is 2 because the maximum, I mean, these are the GCD possible. I've written the GCD over here. Okay, what else? 420, 69. Usually these kind of examples are sometimes for guessing the answers and sometimes for validating whether your approach is correct or not. Sometimes what I do is I form my approach based on these easy cases and then I validate it over the harder case. What I notice over here is 420 divided by 69 is 6 point something, right? 420 divided by 70 is 6, so 420 divided by 69 is 6 point something. What I observe is it is exactly 6. 10 by 3 is 3 point something. But 3 is not possible as the answer. Why? Because 3 cannot be the GCD of 3 different numbers whose sum is 10. 3 is not possible, so then 2. So I'm trying to maximize. So what I'm basically saying, okay, 10 by 3. My average number, the average of my numbers will be 10 by 3, which is 3.3. The average of my numbers in the second case will be 5 by 5, which is 1. Average of my numbers over here, 420 by 69, will be 6 point something. So 6 point something basically tells me, okay, 6 over here is possible, so 6 is the best answer. There cannot be anything better than 6. Why? Because there cannot be anything greater than 6. For example, 7. You can't have 69 numbers which are 7 or multiples of 7. Why? Because 69 into 7 is more than 420. So that's the first thing that I did. What I did was that, hey, you have x and you have n. So definitely, you have been asked to divide x into n possible numbers. So I can say this is, and so some GCD is expected. So this will be something like g into x1, g into x2 dot dot dot, g into xn. What are x1, x2 up to xn? These are positive integers. That means greater than or equal to 1. Okay, and hence the GCD is actually g, and this g I have to maximize. So basically, essentially, x is what? X equal to g into x1 plus x2 plus dot 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 up to xn. Now, what do I know about this? This is my sum of all numbers. What do I know about this? The sum of x1, x2 up to xn. That is basically how many times the g is getting multiplied with each of those numbers to give each of those subproblems. Subproblems means that's how the question is framed, that a problem gets divided into n subproblems. x1 plus x2 up to xn basically can be anything, but must be greater than or equal to n because each of them is a positive integer. So if x is equal to g into something greater than or equal to n, that means x by g is greater than or equal to n. Which means that g has to be less than or equal to x by n. G must be less than or equal to x by n, which means g has to be less than or equal to the average. And that is my first strategy, that hey, 10 by 3 is 3.3 something. So basically, this is my average. 10 by 3 is equal to 3.33. So it has to be less than or equal to 3. My answer has to be less than or equal to 3. What does this give me? That means my answer can be 3 or 2 or 1, whichever maximum one I get. 1 definitely will be the answer, I believe. So yeah, according to the constraints, we need to check the constraints, whether 1 always will be the answer. But anyway, with 3 it is not possible. Why is it not possible? With 3, why is it not possible? Because 10 itself is not divisible by 3. And with 2, it is possible. Why? Because 10 is divisible by 2. So 2 is possible because 2 is less than or equal to 3, which means that 2 is less than or equal to the average. we can have 2 or some multiples of 2 being assigned to all of them. So if 2 into something, let's say over here, 2 into 5 is equal to 10. 10 equal to 2 into 5. Now we have three numbers. We have to divide 10 into three different parts. Is it possible? Always possible. Because 2 into 5 is equal to 3, is equal to 10. 2 into 5 is equal to 10. So if I need to have multiples of 2 in all the three boxes, definitely multiples of 2 are possible. You can have 2 into 1, 2 into 2, 4, and 2 into 2, 4. Or you can have 2, 6, 6, 2, 2, 6, something like this. So definitely here your multiples are 1, 2, 2. Here your multiples are 1, 1, 3 in this way. So basically that multiplicative factor, those need to add up to 5. It's always possible. So there's nothing to worry over there. It definitely is possible. What are the things I need to check? I need to check, hey, my answer will lie in 1 up to x by n. This is where my answer will lie. You can say floor of x by n. This is where my answer will lie, and this is where my answer will lie, and my answer should be such that x is divisible by that. These are the two conditions that you have to satisfy. That's it. And once you satisfy these two conditions, you have to find out the maximum such value. Okay. So if I rename answer in terms of a different thing, let's say z, or let's say g. I named it as g. So g, we have to find out the maximum g. I have to get the maximum g. So definitely I can start from x by n and then x by n minus 1, x by n minus 2, and so on. And that's where I think many people might have got the TLE in the main testing phase. If you go brute force that, hey, from x by n up to 1, I'll check all the numbers whether they divide x or not. Fine, but the only problem is the time complexity. What is the time complexity if you use that brute force? If you use a simple logic that I'll check for everything, for g in range, I don't know in Python syntax, okay, I'll go in this way, from g from x by n to 1. What will I do? I'll basically say if x modulo g is equal to 0, then that is your answer. Return g. This is your answer basically. What is the time complexity? This is the time complexity. So the time complexity is big O x by n, which can go up to, in this particular case, 10 to the power 8 divided by 1, or 10 to the power 8 divided by 2, whatever. And then there are t test cases multiplied by t. So multiplied by 1 or 2 or whatever. So multiplied by 10 to the power 3. So here you can have something like even, let's say 10 or 100. I mean, yeah, for smaller numbers you can definitely do a brute force, but even that is not sufficient because this will itself lead to 10 to the power 9. So this is much greater, much greater. TLE. Here I'm using this kind of a number basically. You can use whatever number you want. 2, 3, 5, 7, 9, whatever. So if I use 10, yeah. It's basically saying that, okay, up to x by 10, even x by 100. It's basically saying that, okay, up to x by 100, I'll do it manually one by one, and then I'll use this. Then also you have 10 to the power 9. So that's a bad approach, and hence we optimize. What are we basically checking over here? We are basically looking at what is our biggest factor. What is our biggest factor? What is our biggest factor less than equal to x by n? This is actually the problem. Biggest or largest factor of x that is less than equal to n. Is it right? Less than equal to x by n. Yeah, less than equal to x by n. less than equal to whatever, less than equal to y, let's say. Y is basically x by n. How can we do that? What is the known way of finding the factors? The known way is up to the square root of x. We have all the factors. We have half of the factors, and the remaining half can be found out by x divided by that. So that is the approach we used, using square root approach. SQRT approach of finding all factors. The time complexity will go to big O of root of x, or x by n, yeah, x by n multiplied by t. Even root x was fine over there. So 10 cube into 10 to the power 4 would have been fine over there. So this is totally going to pass the test cases, no problem over here. I think, I don't know from where it was missed. So yeah, G belongs to this range 1 to n. I'm sorry, maybe I was not sharing the screen. So what I notice over here is that x can be divided into gx1, gx2 and up to gxn. Sum of them gives me x, and I need this maximum g, which lies in this range and is and divides x. And so I know a brute force approach, which is not sufficient, and hence I am now using a very known approach of factors, and this is how it comes. This is a square root approach of finding all factors. I have implemented the same. Let's take a look at that. I'm sorry if I was not sharing the screen for a bit of a long time. Okay, there you go. So what I've done is up to the square root. I have identified all the factors. Hey, if you are a factor, then I'm interested in you. And if you are a factor, then I'm interested in your counterpart as well, y divided by j. And I'm measuring all of them that, hey, if you are less than equal to my y, what is y? X by n. Then I'll consider you. I'm taking the max of all those possible values, and that is my answer. So yeah, it's basically the biggest factor of x that is less than equal to x by n. Okay, it will be root x. It will be root x into t. Since we are finding out the factors of x, it will be root x into t, which is fine, as I mentioned. 10 to the power 4 into 10 to the power 3 is 10 to the power 7, totally fine. Okay, that's where we are in problem B. Now let's look at problem D. This problem is a bit of a mathematical problem. What it says is that there are n children, m are friends, m pairs of them are friends, and the ith pair has a certain friendship value fi. Now there are k excursions, k trips, something like that. She chooses a pair of children randomly, equiprobably, independently. So basically for each excursion, she will choose a pair of students who may be or may not be one of these pairs. Okay, there are m pairs that are friends. The teacher may not choose a pair which are of friends. They may choose a pair who are not friends, and they may choose the same pair multiple times. So it's a equal probability thing. Every time it's like a random value generator tells me this pair, and that pair will be chosen. Okay, so what next? Find the expected value of the sum of friendship values of all the k pairs chosen for the excursions. This answer can always be expressed as a fraction p by q. Okay. Sum of friendship values, expected value of the sum of friendship values of all the k pairs chosen for the excursions. Calculate P into Q inverse mod of this. Let us look at this. 100, 0, 24. 0 is basically the number of pairs who are friends. So if there are no pairs that are friends, nothing comes over here. Now for 2, 1, 10. 1 means that there is one good pair. 1 and 2 are friends and they have a friendship value of 1. Now this is one pair and there are two friends only, there are two people only. So two people means always there will be one pair only possible, whether there is friend or not friend. There is only one pair possible when there are two total people. This is the total number of people, which means that every excursion they will be chosen. The first time when they are chosen, their friendship value 1 comes into the calculation. This is 1. Here understanding the question was a bit intriguing, was a bit tricky. So their friendship value is 1. Next time when they are chosen, by that time their friendship value is increased to 2. Why? Because their friendship value increases by 1 for all subsequent excursions whenever they are chosen. So the same pair is always chosen. Once they are chosen, if you look at it, the first time they have a friendship value of 1, so 1 is chosen. Now their friendship value increases by 1, so now it becomes 2. Next time when they are chosen, it will be 2. Again it increases by 1, so it will be 3. The last time, the 10th time when it is chosen, 9 times it has increased from 1 up to 10. So it has increased up to 10, which means the last time it will be 10. So in 10 different trips, these are my values. These are the expected values. 1 is definitely going to be the value in the first trip, 2 is definitely going to be the value in the second trip, and so on, 10 in the last trip. So in this case, it is not probabilistic, it is deterministic because there are two people. But that is what this question means. Before each trip, what is the expected value that can be obtained? So this is 55. Yeah. Now let's come over here. 312, 211. 312, what does this mean? One pair. There are three people, one pair, one good pair, or one friend, one friendship pair, you can say. 2 and 1 are those friends with a friendship value of 1. So again, going back, 1, let's say, what should we name? Okay, 1, 2, 3. Yeah, 1 and 2 are friends with a friendship value of 1. So, what are the possibilities? How many trips are there? The number of trips are, the number of excursions are 2. There are 2 excursions. So what is possible? How many pairs are there? This is one pair. This pair is X. And the other pairs, let me name them as Y, and this one as Z. 1 and 3 as Z. So I can have XX, XY, XZ, YX, YY, YZ, ZX, ZY, ZZ. If XX, that means both times X is chosen, what will be the friendship value? It will be 1 plus 2 plus, 1 plus 2. The first time 1 and the next time 2. Over here 1 plus 0 because Y is not a friendship pair, so 0. Here also 1 plus 0. Here due to the last X it will be 1, 0 plus 1. Here due to the last X it will be 0 plus 1. If I add them up, what do I get? 3, 4, 5, 6, 7. So I get 7 out of 9 possibilities. These are the 9 possibilities. I got 7 out of 9 possibilities. So my expected value is 7 by 9. That is the answer. 7 by 9. And if we use the modular inverses, 7 by 9 is basically this thing. In a separate session, maybe we can discuss a bit about modular inverses. If you know modular inverses, then you can directly apply it, or even, there are easy ways of applying. So modular inverse, in this case particularly, a to the power n mod m, in this particular case, you can, a inverse mod m. A inverse mod m, you can directly apply it as a to the power m minus 2 mod m. But here I am applying because I know that a and m are coprime. Or you can say directly that a is less than m. That's why I'm directly applying it. And m is a prime number greater than m. So yeah. In this way, you can directly calculate. You know fast powers, you can directly calculate. You don't need to understand this. So 7 by 9, what you can do over here is 7 into 9 inverse modulo m. You can look at a few videos online on how this modular inverse thing works. But that is different. I'm going to focus on this, and the rest of the thing is implementation thing of modular inverses and all these things, which I'll leave as separate. But I'll focus on this, how to calculate this and how to finally reach the solution. Expected value of x. So what is the expected value? For this, I can say, hey, what is the expectation of the value after, okay, again, maybe I was not sharing the screen, not sure. So A inverse mod m, this can be calculated in this way. This is a to the power m minus 2 modulo m. A and m are coprime. In this way, this particular formula can be applied. And now I'm going to focus on how this 7 by 9 comes. So this is the kind of calculation I did. Xx is 1 plus 2, xy you have 1 plus 0, xz in that case you have 1 plus 0. So I'm basically checking how many, what is the value for each of these possibilities and then finding the average. There are 9 possibilities in total, so by 9. Now what I'll do, I'll basically say, okay, the final value Ex is E of X of the E of whatever I get from my first friendship pair, whatever I get from my second friendship pair, and so on. This is the formula we use for expectation. So for my first friendship pair, what is the probability? Based on the probability, what is the how much can I obtain based on the probabilities? So let us focus on, let's say, one particular friendship pair. Their friendship value, let's say, is f1. So what is the expectation? The expectation basically, let's say they have got it I number of times. They have got I number of trips. If they have got I number of trips, what is the binomial probability? I may go wrong with one or two terms, but what is that probability? It's basically which I are we winning. So out of k excursions, which I are we basically winning multiplied by the probability of winning those I, which is um, how many total pairs are there. So 1 by nc2, right? It is n, right? N is the total number of pairs, right? Yeah, n is the total number of children, so nc2 is the total number of pairs. So 1 by nc2 to the power I number of times it has won. So this is the probability of winning, of getting chosen I number of times, multiplied by not getting chosen I number of times. So nc2 minus 1 divided by nc2. Not getting chosen k minus I number of times. These many times we are not getting chosen. This, I think it's called binomial probability distribution or whatever. So yeah, this is the probability of this pair to be chosen k times. I don't care which pair it is, whether it is a pair of friend 1 and friend, I mean, people 1 and 2 or people 1 and 3 or people 1 and 4, I don't care. By this time I have understood this much. The values matter to me, not the people and those things. Okay, coming back. This is the probability, and what is the value that I'll get out of it? If it is chosen I number of times, that means my value will be something like this: f1 plus f1 plus 1 plus f1 plus 2 plus dot 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 up to f1 plus k minus 1, right? Which essentially boils down to something like this: kci multiplied by that nasty thing, nc2 to the power I multiplied by nc2 minus 1 by nc2 minus 1 sorry, k minus I multiplied by I into f1 plus, okay, it's not k minus 1, it will be I minus 1 over here because I times plus I into I minus 1 by 2. Up to I minus 1, I'm adding all the numbers, I into I minus 1 by 2. This I have to sum up for all the i's, right? This I need to sum up for all the i's from I equals to 1 to k. And that's where uh, what probably some people refer to when they call code forces as math forces nowadays. Okay, so this is some basic mathematics, and now you have to add it for all the fi's. So if I add it for all the fi's, summation of e of all the fi's, expectation of all the fi's for all I gives me the answer. This is my answer. So what will the answer come to be? If I pick out all these fi's, if I pick out this particular factor, I can do that. I can basically say, okay, it will be summation of fi's, which can be totally a separate thing for me. Summation of fi into summation of I equals to 1 to k. This particular thing, let me name it as something. This is g of I. So g of I multiplied by I, this particular I am bringing over here, okay, plus summation, okay, this is separate, into I have got plus summation of fi for all the, this factor will basically be the same for all the pairs. So I can just multiply by m, which is my number of pairs, right? M is the number of good pairs, if I understand, if I remember correctly. There's a number of pair of friends. So I can say, yeah, m multiplied by summation of gi multiplied by I into I minus 1 by 2. Yeah. Summation of gi into, this is for I equals to 1 to k. That's it. I just calculated this. So GI is that complex thing. I have to calculate that thing. I just calculated this. So I'll try to show how I did this in my first attempt, which went, unfortunately, which led to a TAD. Fortunately, that was shown in the pretest itself, else that would have hurt it. So let us see. I did it k times. Why did I do it k times? If you see over here, I'm doing it I equals to 1 to k. All these things, these factors, I'm doing it. You will see this KCI, you will see this power. This is NC2 inverse, NC2 inverse to the power I, and you will see this NC2 minus 1 divided by NC2 to the power k minus I. This will be k minus I. Let's see. KCI, this is KCR. So I formed this KCI over here. And then this is NC2 minus 1. Okay, you can see over here NC2 minus 1 C k minus I modulo mod. We are finding it. We are finding first of all NC2 minus 1 and then raising it to the power of k minus 1. NC2 minus 1 to the power k minus I. Sorry, k minus I. nc2 minus 1 to the power k minus I. If I go over here, nc2 minus 1 to the power k minus I. So I have found out this numerator. I have found out this denominator nc2 to the power I. This denominator also I have got nc2 to the power k minus I. Let me see. Denominator is this nc2 to the power k. I have found k over here. Okay, this is because multiplying these two denominators give me nc2 to the power k. So nc2 to the power I into nc2 to the power k minus I gives me nc2 to the power k. kci I have got the denominator. I have got this numerator. What next? Now the result. Now I'm just multiplying them. And I'm doing this mod inverse, which is mod inverse I have calculated with a different function. This is the denominator. The denominator I've already calculated, so I need 1 by denominator. Denominator I've calculated, I need 1 by denominator, hence I did the mod inverse. I'm not dividing. Dividing is a very difficult thing when you have modular, all these things. Not always impossible, but again, characteristically difficult. And now I'm forming this answer. I'm basically adding the things, and the two parts that I showed you, this is the first part and this is the second part. The first part is basically this part, and the second part is this part. Okay, so yeah. Now, the interesting thing is, after so much of effort, though the code looks so clean and in a way mathematically intensive, it gave me a TLE. So what did I do wrong over here? I did wrong in the code. It gave me a TLE in pretest 3, which means pretest 2, up to there everything was fine. What is the problem? K times I am doing this fast pow and mod inverse. Fast pow and mod inverse. Fast pow and mod inverse. Both have good time complexities. Fast pow will basically so fast power will basically take how much? Log of something, right? A to the power n. It will be log of n. So these are all logarithmic time complexity. These are all logarithmic time complexity. But now if I look at the overall time constraint, let's look at that. So over all the test cases, the sum of k does not cross 2 into 10 to the power 5. I'm sorry. And what am I doing? For each k, I'm basically having this factor of denominator, and denominator can be quite large. For example, the denominator can go up to 10 to the power 9. So log of 10 to the power 9, something like that. Basically, denominator it's basically the log of this factor. Fast pow, so it will be logarithm of the second factor, which is b, which means log of 10 to the power 9, which is around 30. So summation of everything, and doing it so many times. I'm doing the fast pow so many times, mod inverse, so again a factor comes in, quite many multiplications, modulus operations, etc. So definitely doing this mod inverse and fast pow operations is bringing us the cost over here. NCR, let me look at NCR. What will be NCR? NCR I think is the bottleneck here. What is NCR? NC2, and over here it's that thing to the power k, 2 factorials. Yeah, and I'm forming KCI at every step. So KCI would actually go to a big number. If I look at my NCR implementation, now probably I understand what why it went wrong. Yeah. So this is big O n kind of thing. That's where it was a TLE. So one time big O n didn't matter, but if I'm doing it k times, then this becomes k into n. So it was not due to the log factor. The log factor was not a problem. Fast power and mod inverse are totally fine, but the NCR was the culprit. That's the only thing I needed to solve. This is big O n or m n or r, whatever. Actually big O n. So yeah. Now big O n or whatever I'll leave over here. big O N or R, depending on implementation. So this is a big thing. When it gets multiplied by k, that's a big thing. And hence, so what I did next was I did an improvement. I did improvement on the log factors as well. If you look at this, yeah. So if you see over here, I have done none of those things inside here. I have done not a single fast power mod inverse NCR. Now we know fast power mod inverse could still say over here. In other problems which will be far more difficult, maybe you can't do a fast power mod inverse. So then you have to keep this in mind. What I did over here, sort of similar things you have to replicate, which is I calculated all those values in advance. For mod inverse, so if I go one by one, I had calculated the sum, then I calculated the inverse of NC2. I basically said that, hey, the first inverse, let me find out what is this particular inverse, which is NC2 to the power k, and then NC2 to the power k inverse of that, or basically NC2 to the power minus k. I am basically multiplying that by NC2 once. I am not dividing, I am multiplying to get NC2 to the power k minus 1, k minus 2, and so on. In this way, I am multiplying. So basically, what I have used over here is a tricky thing, which is NC2 to the power I is equal to NC2 to the power I plus 1, so NC2 to the power minus I, or something like this. Inverse of NC2 to the power I is equal to inverse of NC2 to the power I plus 1 multiplied by NC2. So I have this value. From here I am finding out this value. If you look over here, from the I plus 1 I am finding the ith one. From the I plus 1, where is it? Yeah, from the I plus 1 I am finding the ith one. Similar I am doing for all of this. NCR I am doing again in the similar tricky way. I am finding the factorials and the inverse factorials. Again, same strategy. Inverse factorial of k I am finding first. And then what I am doing is I am basically finding the inverse factorial of previous numbers from the next numbers. That is easier because that needs multiplication. From I inverse, I factorial inverse, if I want I plus 1 factorial inverse, I need division or something like that. But for going back the way, I need multiplication. That's the strategy I am using. And by this time, those array values are sufficient for me. Now I realize that only this NCR was needed. So these things were not, okay, these things were not really needed. But anyway, maybe they were meant for you so that I could show this to you today. So that's it. So if you see now the time complexities, all these operations are happening only once. Like k times only multiplication is happening. Multiplication k times is fine. But mod inverse is happening only once. Fast power is happening only once. NCR is happening only once. Right, they are not happening in loops. If such operations happen in loops, sometimes you have to worry. I'm keeping everything outside loop. Over here also mod inverse happens outside loop and only multiplications happen inside loops. When you are able to reach to this stage that only multiplication happens inside loops, mostly it is safe. You can move ahead. Fine, that's it. Now, there is this last problem. This has been a long session, but still I'll touch upon the last problem since I mentioned it. Please take a look at this problem. I'll just give an outline of this. So it basically says that there are n points numbered 1 to n on a straight line. M harbors. This is question E of Div2. So there are harbors at the points 1 and n. There are m harbors, each located on some point or the other. That those will be given over here, the positions of the harbors. But at the end points, two are definitely located, 1 and n. And a ship is located at exactly one ship at one of the endpoints. So there are n points over here, 1, 2, 3, 4, 5, 6, 7, 8, dot, 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 n. You have a ship over here, you have a ship over here, ship, ship, and you have one harbor here, one harbor here, other harbors at few places like this one, and so on. Okay, so harbors are some of these points, not all of these points, and you need to say, okay, for a ship, what is the cost of moving a ship to its next harbor? So cost of a ship to move to its next harbor is given over there. For example, basically this ship, it's not at a harbor. For this ship, it's already at a harbor, so I'll say that the cost is 0. It is given in the question. For this ship, it is not at a harbor. So what is the cost of moving it to a harbor? The formula given is, it's equal to the product of the value of the nearest harbor to the left and the distance of the nearest harbor to the right. So for this one, let's say, it will be the value of, let me name this h1 and h2, value of h1 multiplied by this particular distance multiplied by d. Okay, so this is the cost of moving it to h2. I didn't solve this, I'll just leave a very short intuition or hint on how you can solve this problem with, of course, sufficient details for you to give it a try, give it a step. So this is a range query problem. It's basically saying that there is a query to keep on adding harbors at some point with a certain value, so that is 1xv, and you have 2lr, which is basically that from L to R, find out the sum of the cost of moving all the ships from L to R to their nearest harbors. So from L to R. So if L is this and R is this, the question is basically, what is the total cost of moving them to their nearest harbors? Fine. Understandable question. Yeah. From if this is L and this is R, then from L to R, their nearest harbors is what we are interested in. Fine. What next? Next point is, you don't need to move the ships. The ships will remain where they are. You just need to calculate. Fine. Now coming back. Let us understand what kind of problem is this. What do I need to tell? I need to say the sum of costs. So this is a range query, right? I am querying about a range of points. For these points, if I have to maintain the information for these points, what are these points? Ships. What are these points? The points are ships. And for these points, if I have to maintain, hey, who are their nearest neighbors to the left and to the right, then this is a range query. For all those ships, I need to add those information, add and multiply. I'll take ships as those points. You can analyze, hey, if I take harbors as those points, what I can do, what I may not do. But this is basically the idea which I could reach when I read the question instead. Now, keeping these points of ships in mind, what do I get over here? 1xv. This after all is a point update from the harbor point of view, that I'm introducing a harbor. But with respect to ships, there are so many ships. When I introduce a harbor, what happens? When I introduce a new harbor, let's say over here, what happens? The ships to my left will consider me as their right neighbor, and the ships to my right will consider me as the left neighbor, which means for these ships, the ships to the left where I'm introducing the harbor and the ships to my right, they are all experiencing a change, yes or no? These all will take this new harbor as their left harbor. In fact, I'll keep it this way. This guy is entering over here. So these ships will consider it as their right harbor, distance from the right. So these ships This ship will consider it as right harbor, which means distance from right harbor is 0. And these ships will consider as left harbor. Okay, I should only worry about this. Yeah. So these ships will undergo changes in their nearness to the locations of harbors. So again, the number of ships is not a single one, there are multiple, which means this is also a range update. When I introduce a harbor, I'm updating the information for multiple ships, so it is a range update. With respect to harbor, it can be a single update. With respect to the ships, multiple ships are getting affected. With respect to query, multiple ships are being queried together or are sort of even involved together. So, range update, range query brings to our mind, in this case, when I'm introducing a harbor, we have to see the nature of queries. So, if I, what basically was the question? Sum of the cost of moving all the ships here. So I can say, I can use some of the data structures that are meant for these range updates and range queries. There are a number of data structures. You can rest with something very commonly used, which is segment tree. But when this range update and range query comes together, we use a technique called lazy propagation. If I'm not wrong for this case, we use lazy propagation. Why? Because range update, range query, if you don't use lazy propagation, range update can take big O n time, which we don't want. So we have to use lazy propagation. Okay, so now what next? Yes, how to propagate? For each ship I can contain in my segment tree. In my segment tree, for each x I can store what is the value. I can store the value. Let's say that is fx. Now what happens? If a certain if a harbor enters at position car, what can I say? That from the left, there will be a left harbor already present and a right harbor already present. So from the left up to the car, all will consider this as their new right. I can say from this left to the car, all ships are affected, will consider this as the right. And from open-ended car to closed-ended right, I mean, can be closed or open-ended, doesn't matter, 0. So all ships will consider this as their left. So now what should we do? Whenever any of those comes, I can use an algorithm. I can say, okay, for all ships to the left of car, or for all ships in that particular range, let me use one of the range, in left to car, for all the ships in this particular range, I can say that the value is going to decrease. So the value is basically going to decrease by what? By the value of the left ship multiplied by the right minus car. Why? Because before this change came, from this ship we were checking the distance up to the right. Now we only need the distance up to the car. So this particular distance gets saved. So right minus car. And how do we get v left? The sequence of ships can be maintained, this sequence of harbors can be maintained in a tree set kind of thing. We can use a tree set to store harbors by position, right? Then we are done. And next, what can we do again for all ships? For all ships belonging to curve to right, fx minus equal to or plus equals to um, so the for the ones to the right, it is what changes? It's the distance changes, distance from the current position. So v car minus v left. If I see something like this, from this position, this is where I'm introducing the harbor. All of these are going to say, okay, my value, instead of that value, it is going to get this value, and their distance remains the same. Is it? Their distance remains the same. Their distance was whatever. Their distance remains the same. So it's a multiplicative change, you can say, or you can do something like this. It's basically the value changes. So v car minus v left multiplied by v car, because that's a nearer one. So v car minus v is basically the value, yeah. So this particular value multiplied by the existing distance, whatever is the distance. And the distance is tricky. The distance is going to be right minus x. So this is the change for every shape. You have to propagate this change, and the lazy propagation will slightly make it tricky. Why? Because this x is variable. If you want to apply this change over a number of nodes together in segment tree, it is slightly tricky. But again, you can divide it into multiple parts. For example, this particular thing, you can basically say this change, they all can be accumulated. They are all plus minus changes. That is why I did not do multiplication over here. I could have easily done multiplication. I could have said, hey, fx multiplied by multiplied by something like v car divided by v left, something like that would come. But I can't apply the multiplication, or maybe I can apply. I haven't given that much of thought into it. You can explore whether that can be an easier option or not. But I am having a plus minus change above, and I am having a multiplication change above. Of course, you can also have a multiplicative change over here. Anyway, the answer should always be possible. If it is either multiplication division or it is either plus minus, you can use that kind of a commutative property, etc., which this kind of segmentary actually needs to be present. So over here, if I have to do something like this, I have to take it in this way, that okay, there is a collective change and there is a position based change. The position based change also can be accumulated. When I want to sum over those position related statistics, I can do it. I know what those positions are from L to R. So those x factors, I can say, okay, for x, if the coefficient, I can express it as something like this. I can express it as something like a plus bx, where a is nothing but v car minus v left into right, and b is also v car into v left, v car minus v left. In this way, I'll have some a and some b, which will again be a cumulative result of multiple such operations that have happened. And when I get those a and b, I can then, yeah, I can basically keep on maintaining that a and b, and then I can apply it. So there are multiple ways to solve this problem. Now, while I'm speaking this, I think that multiplication division also might be a possibility. So definitely you can explore that. But basically, things should not be overcomplicated. Um, so there is a video you can find if you search by my name. I have taught segment trees in a separate video quite some time back from now. So you can look at how I have applied lazy propagation, how I have applied segment tree concepts to solve some easy, medium, and some difficult problems. And that's it. So this is what should suffice to solve the problem. I haven't really tried implementing this. It has been a number of months since I've last implemented a segment tree, so you really need that flow. So I didn't try during the contest. I got involved in something else, and after the contest also I didn't put any time. If I Even if I got any time, I didn't put any time. So yeah, I'll expect that you understand the problem. Ask if you have any doubts. So the cumulative part of x that I was mentioning is basically from L to R. If you have to add x, you already know what the answer is. It's a R into R plus 1 by 2 minus L into L minus 1 by 2. So that kind of accumulation, etc. These are easy things. But basically, you need the practice in segment trees to really get going in these problems. So that's it. The sixth problem is on geometry. I'll not go into that. But that's it. I hope you have got some good insights on how these problems are solved. Gradually, we will see if we can level up our difficulty of questions. So, yeah, that's it for the day. Tomorrow or day after tomorrow, I think we have a contest. Let's see if we can meet shortly after that. It's through this upsolving and these debugging practices that you can keep yourselves better, make yourselves better at problem solving. Maybe in some other sessions, I can discuss more about mathematics and uh, debugging techniques or problem detection techniques, approach detection techniques that are used very frequently in computer programming. That's it for the day. Take care, keep coding, and let me know in your feedbacks, in comments, etc., how you have felt about the session. Don't give that kind of a feedback, or don't let the difficulty of problems become a factor in your feedbacks. Let me know what different can be done. I'll probably be exploring some ways of how I can give back some value to the community. So this might be a rudimentary form in that effort, in the direction of that effort and intention. But anyway, let me know how you feel, and what are the areas where you feel things can definitely be changed or can go better for you. You can connect me on LinkedIn, and also on these Codeforces chats. There are some people who have connected in the past. So then you can let me know whatever you feel, what doubts you have, etc. in the comments. Take care. Let's grow together. Keep coding. Bye.